Okay, now we're going to talk about the anaerobic respiration and the fermentation. The anaerobic respiration functions like aerobic respiration, but it utilizes oxygen-containing ions, not oxygen, but oxygen-containing. It doesn't have free oxygen as the final acceptor. Instead, you're going to have nitrates that use the nitrate reductase enzyme. Most of the obligate anaerobes will use the hydrogen ions that are made during glycolysis in the Krebs cycle to reduce some compound other than oxygen, because oxygen is not the final acceptor. Here you've got glycolysis, where we split the glucose into two pyruvates. Then it goes into the Krebs cycle, and everything's the same, and then into the electron transport chain. The only difference is there's no oxygen involved. The electron acceptors are going to be the sulfates, the nitrates, or the carbonates. And we don't know how many ATPs are made. It depends on the microbe. Fermentation is done in the absence of oxygen, and it includes incomplete oxidation of glucose. The terminal electron acceptors are going to be organic compounds, and it will yield just a small amount of ATP, 2 ATPs, and produces either ethyl alcohol or lactic acid. Widely used in food. That's how cheeses and yogurts are made, in alcohol, and thousands of chemical compounds. And here's the process. We got glycolysis happens, we split glucose into two pyruvates, and then it goes into fermentation. No oxygen's available. The last electron acceptor is going to be a pyruvate or this acetaldehyde, which is an alcohol. So if we compare aerobic respiration, anaerobic respiration, and fermentation, and look at these, we see the pathways involved for each of them that we've discussed. The final acceptor, aerobic respiration, is oxygen. Anaerobic is organic molecules that are oxygen-like. And then we have inorganic ions for anaerobic metabolism. We're going to produce ATP with all of them. But you see other things are produced as well. And we find this happening in aerobes and facultative aerobes for aerobic respiration. Anaerobic metabolism is in your obligate and facultative anaerobes, and your anaerobes are for the anaerobic metabolism, respiration here. So the last thing we want to look at in this chapter are some of the crossing pathways of metabolism. Many times they're bidirectional, which means they're amphibolic. This improves efficiency. The catabolic pathways have these metabolites, these molecular intermediates, that can be diverted to anabolic pathways. So they're bidirectional. Your pyruvic acid can be converted into amino acids, and amino acids can be converted to energy sources. Your G3P is converted into precursors for your amino acids, your carbohydrates, and your fats. See, bacteria don't carry all the chemicals that they might need with them. They carry a base essential chemical, and then they convert it to what they might need at the time, because it's more efficient. So what includes incomplete oxidation of glucose or other carbohydrates in the absence of oxygen? Fermentation.